Right, so this is systems of linear inequalities, and this is a first video. So our learning goals is to be able to model and solve problems algebraically and graphically using linear inequalities in two variables, and to algebraically and graphically solve systems of linear inequalities in two variables. So the essential question: how does solving linear inequalities apply to the real world, and what methods can be used to solve systems of linear inequalities? So for this first video, we're going to go through the different ways that we could solve for equations, but we have to first start with how to graph a line. And this first one is graphing using slope and y-intercept form. My favorite. So in this version, your y is alone, and I'm just going to actually write the formula off to the side here. So you might have heard of y equals mx plus b. Your y is by itself. M represents the slope. X is your other variable. And your b is your y-intercept. It's that starting point. So here in the first example in A, here's my y-intercept. It's my starting point. And on your coordinate plane, this is your x number line, and your vertical line, is your y number line. So my y-intercept is positive 4. So on the y number line, I'm going to plot a point at 4. So there's my first point. Now, the value that's with your x is your slope. So your slope in this example is -5. Now slope is equal to rise over run. So my rise is -5. What would be my run? So if I wanted to turn -5 into a fraction, if I just write 1 below, it doesn't change anything. It's still the -5. So my slope here is -5 over 1. I go down 5 and to the right 1. So there's my new point. And if I want, I can draw another point by going down 5 over 1. And I have enough to connect my points. So I'm going to go ahead, connect my points, and there's my line. So in example B, I have to graph the line y equals 3 over 4x plus 1. This is in slope-intercept form because my y is by itself. I have 3 over 4x, so I have a slope, and I have a constant. So this number all by itself is my y-intercept. So I'm going to plot a point at 1. So it's my beginning, it's my starting point, and then my slope is 3 over 4. Positive 3 over 4. So because it's positive 3, I go up 3 to the right 4. I always go to the right. So 1, 2, 3, up 3. 1, 2, 3, 4. Oh, that doesn't look very good. Right here. There we go. If I want to draw another point, up 3 over 4. There we go. All right, that's enough to connect my points. There's my line. So graphing in slope-intercept form is my favorite. I find it's the quickest. Now, here it wants me to rewrite the following in slope-intercept form and then sketch the graph. So everything is over to the left side. I need to move it to the right. So I need to get y by itself. So I'm just going to write this over on the right side so I have a little more room. Now I need to get this y by itself. So I'm going to move over this 2x by subtracting 2x from both sides. And then I also have to move over that -9 by doing the opposite. If I add 9 to both sides, it gets my y by itself. And now I'm in slope-intercept form. So the digit all by itself is your starting point. And I always start on the y number line. It's my y-intercept. So I'm going to plot a point at 9. There we go. And here's my slope. Now if I want to give it a bottom, so if I want to write it as a fraction, I'm just going to put it over 1. So it's -2 over 1. The negative means I go down. So I go down 2 to the right 1. So there is my new point. If I want to give another one, go down 2 over 1. And I can keep going as much as I want. Connect my points. There's my line. Now this one wants me to solve for the following using a table of values. So that is your good old X and Y chart where you get to decide what your X values can be. You plug it into your equation and solve for the Y. Alright, so this is just a bunch of math. So now I'm going to get Y by itself. Mm, 8.5. There we go. So all I'm doing is whatever X value I chose, I'm plugging that in for X, and I'm solving for Y. Okay, and for time's sake, I'm going to go ahead and plot those points, and I think that's good enough. So here I got my first point. It's -2 and 8.5. So it's a -2 on my X value and 8.5 on my Y. So about there. Now, the next dot, a -1 and a 5. Oh, my other one disappeared. Hold on. There we go. 0.3, 0, and 1.5. And then I had 1 and -2. So that is definitely enough points to draw a line. So this method works. It's just not my favorite because it is time consuming. Alright, so for the linear equation 2x minus 3y -6 equals 0, state the x-intercept, state the y-intercept, and then graph the line. So this is method 3 of using your x and y-intercepts. So in order to solve for your x, y-intercepts, you need to plug in 0 for one variable and solve for the other. So here, if I wanted to state the x-intercept, anything that falls on this x number line, the value for y is 0. So if I plug in 0 for y, I will solve my x-intercept. Alright, so my x-intercept is 3. So my x number line, I'm going to plot the point 3. If I want to solve for my y-intercept, I am going to plug in 0 for x and solve for y. And y is -2. So there, I have 2 points. That's good enough to make a line. So I'm going to connect my points. and my line is made. Great, 3 more examples. Sketch each linear relation and identify the intercepts. So here, I'm going to write this so that y is by itself. Notice that there is no x value. When I move that -3 over, so if I add 3 to both sides, I get that y is equal to 3. So on your y number line, you're going to plot 3, and this line has no x value. I am not crossing at all on that x number line. All my point values must have that y equals 3. So this is actually a special case where I'm drawing my line straight across. So at all these points, your y value is 3. It never changes. Now for your x and y-intercepts, for graph A, we only have a y-intercept, and that y-intercept is at 3. There are no x-intercepts. This next value, I'm just going to move over that 4.5 to get x by itself. So if I subtract 4.5 from both sides, I get that x equals -4.5. There is no y value. There's no y variable. So I'm going to find on my x number line where x equals -4.5. So right here. And this is going straight up and down at all these points. Hopefully your line looks better than mine. At all these points, x is always -4.5. So your x-intercept is -4.5, and there are no y-intercepts. Lastly, y equals 0. So the point where all your y values equal 0. So here's that point 0. Over here, y is still 0. My y value is still 0. Here, here, this whole line, y is equal to 0. And this one has a y-intercept of 0. And it also has an x-intercept. This is a special case because it happens to fall right on the origin. So you can do the following practice questions. So practice number 1 under systems of linear inequalities. Choose any 5 of the graphs. If you're in class, I have a handout for you.